Hello and welcome. If you like robots of all shapes and sizes, then you're in the right place. If you enjoy BattleBots and CouchBots and AIs, oh my! And if you're looking for an extra challenge, like collaborating on the same robot when you're not even allowed to be within 6 feet of each other, then you are in luck. Allow me to introduce to you the Multidisciplinary Robotics Club here at RIT. My name is Sid Davis, and I will be your host for this presentation. Now, I'm sure you're wondering, what is MDRC? And to that I say, the best way to describe a person or an organization is to list what they do. And so without further ado, here's what we're all about. MDRC provides students of all majors at RIT the opportunity to use our clubroom as a makerspace, with access to a soldering station, electrical test equipment, prototyping materials, and every tool you could ever need. We also host workshops. Since we attract students from every major, not everyone has the same skill set as one another. We always try to hold info sessions throughout the semester that help to educate those who wish to know more about various skills that they don't learn from their majors. These skills consist of things like soldering, computer-aided design, programming, and much, much more. With a multitude of team projects, we helped get our members to competition. That is, when the competitions aren't getting canceled due to pandemics and everything. But by taking care of the documentation, it allows our team members to focus more on the aspects that they really enjoy, like building the bots. And lastly, what's more gratifying than inspiring the younger generations? We attend as many showcasings in the area as we can fit into our schedule. And so, we love to show off what we've been up to. We like to impress our families that are in the area, and we love meeting other makers, such as ourselves. Now, I think that's enough about the club, but let's chat with one of those makers now. Gerald, take it away, please.
Hey y'all, my name is Gerald Atwood. For this video, I will be introducing our club's several BattleBot teams. To start, I want to introduce our 3-pound BattleBot team and what they have accomplished this year. To prepare for competition in 2022, we have redesigned our bot to use an egg beater vertical spinner, with an aluminum bar and steel tube variant. Its frame, which also acts as its armor, is made out of high-density polyethylene, also known as HDPE. It has 2 wheels and, in the case the robot is flipped during combat, is designed to drive with inverted controls. The robot uses 3D printed parts for its weapon pulleys and nut holders. Due to the COVID-19 pandemic, our team is unable to compete in 2021. Our current goal is to have our robot complete by the end of 2021 and ready for competition at Motorama 2022. Moving on, our 30-pound team has temporarily retired our featherweight bot, Kronk, due to a lack of available competitions. Instead, we have been working on weapon prototypes for the sportsman weight class. One of these designs is the aptly named Flywheel Hammer, a hammer that clamps onto a spinning flywheel, transferring its energy into the hammer for a powerful impact. Our second design, called the Impact Spear, is a compact flywheel-powered spear that transfers as much energy as possible into a single point. While we don't have any competitions to attend this year, we plan to have a new sportsman weight class BattleBot ready for spring of 2022. Finally, our third BattleBot project is an experimental game we're calling Twitch Plays BattleBots, where 2 teams control their own BattleBot collectively through a chat room on each team's corresponding Twitch channel. Each team earns points by knocking out the other team's robot. Both teams can vote on what robot they control, as well as what obstacles are on the field. To follow this project or check out the stream, head to our website for the channel link.
Hi, my name is Ryland Sharon, and I will be walking you through MDRC's PackBot project. PackBot is MDRC's advanced maze-solving robot, built to compete in Harvard University's PackBot competition. The goal of the competition is to build the best small robot that can autonomously play a game of Pac-Man when provided with all the same information as a human player. Our robot won this competition in 2019. The robot uses a Raspberry Pi to communicate with Harvard's server. The server provides data on the game's state, which the PackBot uses to avoid the 4 virtual ghosts and collect as many pellets as possible. In the physical world, the robot uses infrared sensors to navigate the model maze. Due to the COVID-19 pandemic, there is no PackBot competition this year, but we still worked to improve our robot. We designed a printed circuit board to interface our Raspberry Pi, power module, servo drivers, and 5 infrared sensors. We modeled and 3D printed a chassis, and we are using simulations to test our autonomous navigation software. This iteration of the MDRC PackBot is nearly finished, and we are looking forward to participating in Harvard's competition next spring.
Hey y'all, I'm Gerald Atwood, and I will be introducing our club's AMOS project. AMOS is an autonomous robot that competes in the Intelligent Ground Vehicle competition all the way over in Rochester, Michigan. The competition is all about navigating around an obstacle course while staying between two lines, all while safely delivering a payload to the end of the course. It being an autonomous vehicle, AMOS has to do all of this on its own without driver support. Our robot utilizes technology such as LiDAR, computer vision, neural networks, and GPS to accomplish this. This project is still in development, with changes being made to accommodate work during COVID-19. If you are interested in the project and want to learn more, feel free to email us.
Hello everyone, it's Sid Davis again. This time, I'm here to tell you a little more about our University Rover Challenge team. Now, MDRC is in collaboration with another organization on campus called SPECS. In fact, you should really look at their video after you're done watching this one. We are combining our efforts and skill sets to create a Mars rover that will compete at the Mars Desert Research Station in Hanksville, Utah. While SPECS focuses on creating the rover's base, we are focusing on making a robotic arm that attaches to its top plate. We've had a rigorous design phase these past 2 semesters, which turns out to be very pandemic friendly. Now, we've had to ensure that the arm that we create can perform a multitude of tasks that would be expected of it in realistic Mars conditions, so it's important to nail down as many details as we can before prototyping begins. By the end of this semester, we will have about 5 full revisions done of the mechanical design alone, along with a software interface that should communicate with the rover, our electrical control system for each joint, and we'll also have some state-based structures in software that keep track of the present position of the arm. SPECS and MDRC are looking to go to competition in spring of 2022.
Hey y'all, it's me again. For this section of the video, I will be introducing our club's CouchBot project. Since we have retired our club's old CouchBot from fall of 2019, we have overhauled the design to include new steel frames for added support, as well as an optimized power delivery system that makes better use of our 12-volt batteries. We're still working on the design, so if you're interested in helping out in building it, please come and join us. Since we're nearing the end of the video, I'd like to ask that you consider following us on Twitter using the link on screen. If you're interested in joining our club, use the QR code to join us on campus groups.
Thank you for watching our video all the way to the very end. You must like robots as much as we do. We hope you enjoyed our video presentation, and hopefully next time we can show you our progress in person, like the good old days. Check out some other videos Imagine has to offer. And last but not least, stay safe everyone.